a little bit different from our lab real oscilloscope, but basically the same. Okay, the same make, just a different generation of the model, and also the same frequency, 300 megahertz. So let's learn what we are seeing here. The oscilloscope is a very, very important. If not the number one, I would say it will be number two important electrical engineering major equipment we have to be very familiar with. All right, today let's become familiar with this control panel first. Okay, from this panel you are seeing this part is obviously the display and display of your result. And here the most significant thing is four big knob here with different colors, nice, and four small knobs here below it, right, below them. Right? So basically you can tell this actually what they called four different channels. Okay, four different channels. By channels, it means this guy can help you display up to four signals. What does the oscilloscope do? Just displaying the signals. Of course, you need to input your signal into this guy, right? Into into the scope. So where to input them? Here. For channel 1, you see this is the indicator light is 1. When it is on, there's a light because you can shut it off. Okay, because by pressing this this rubber, right, pretty rubber material, press it once, it can be shut off. So you won't be able to see the corresponding yellow color waveform here, okay, because you shut it off. If you want to watch it, you can turn it on by press it again. We input your signal into here, and this is down here is the input to this scope. The connector is a special connector called BNC type connector. Okay? So we have up to 4 channels here. We obviously just need to talk about one of them, so you understand all of 4, right? So to 4 channel, first channel, which is labeled in yellow color, is very nice to color code it because the corresponding displayed waveform here is also yellow. So you can tell this yellow waveform is nothing but the signal of channel 1. Okay, it's a really color coded. So yellow color is channel 1 signal. Okay, and the top knob, bigger one here, this guy. This big knob is changing the vertical division. What does it mean by vertical division? You change the vertical division is changing how much one vertical division like this represent. It might represent 10 volts, might represent 5 volts. So if you increase this vertical division, the displayed signal gonna become bigger or smaller. The same signal, okay, the same signal. You're changing division, not going to change the signal. You can't change the signal. However, you're going to change the display or say the look of the signal in the oscilloscope. So think about it. If you increase the division, vertical division here, from 5 to 10 volts, the displayed signal going to become smaller or bigger. It becomes smaller and exactly half. Right? You think about it, if your division here is representing 10 volts, and if your signal is 10 volts big, it just occupies 1 division big, right? However, if you increase your division to 20 volts, your division right now, 1 division is representing 20 volts, which is increased. Then how big is your signal going to look like? Half division, right? Because your signal is 10 volts, you cannot change that. Right now, your one division is 20. So how big going to be displayed? Half division. Because my signal is 10 volts. Your 1 division is 20, then my 10 volts just a half division. Right? This is a result of increasing your vertical magnitude division. Okay. Here, we of course also have a horizontal division. A horizontal division like this, right? This is one horizontal division. This one division is representing the horizontal, which is time. This can be changed by here, up here. This one knob, obviously all the 4 channels are sharing the exactly same time axis. That's why there's only one time division knob, right? Which is this guy up here. If you change this guy, you can change how much time one horizontal division here like this represents. Okay? You increase the division horizontally, what the signal can look like, become bigger or smaller. It's actually maybe easier to be illustrated by here. For example, if your original horizontal division is 1 millisecond, and your signal is a sinusoidal with 2 milliseconds long. This is your signal. If your division is 1 millisecond, then displayed signal is like this, right? Because 2 division is 2 milliseconds, and this is your signal. However, if you increase your division, 1 division is actually 2 milliseconds. What does the signal look like? Shrink to this, right? Exactly half. Because 1 division right now is representing 2 milliseconds, and your signal is 2 milliseconds long. We cannot change this guy, right? So 1 division is 1 millisecond, then I'm gonna occupy 2 divisions. But if you increase your division to 2 milliseconds, then I just need 1 division to represent the same signal. So this is the vertical and horizontal division mean to you. Okay? You can zoom in or zoom out your signal. You want to zoom in, then you need to decrease the division vertically and or horizontally.
Professor?
Yes.
How do you know what each division is?
Very, very good question. They are the specific number value is labeled here, up here. So you can see, first of all, you see in the yellow color 1 labeled in front, right? This means the first channel division, because obviously you have 4 knots, right? 4 big knots here to adjusting the vertical division. They're all color coded, right? So to channel 1, you might have vertical division as here as saying how much vertical division here is telling you for channel 1. It's 200 millivolts. It's millivolts. M on top, V on the bottom. Is written in this way. And then slash. The slash means per division. Okay? For the same reason, what is the channel 2 vertical division? Second
Looks
one.
like they're all the same.
Exactly. Look, these are vertical divisions. Okay. Answer to his question. Okay. This vertical, 4 channels. The horizontal one, where is it? Here. Can anyone read what is the value here?
It's 2, and then I can't say the unit after that.
That's right. It's 2 milliseconds. M is milli. So 2 milliseconds per horizontal division, which is time division. Okay. Here are the specific value. You can know. Okay. And these are 4 big knobs here, tuning the vertical division. The below it here, these 4 smaller knobs. These are for what? These are for position. What does it mean by position? You can move your signal waveform up and down. Okay, you can move up and down, and you see here these 2 arrows. 2 arrows, very meaningful, isn't it? telling you is moving up or down. And because once again, the oscilloscope just try to display whatever you input into this 4 BNC terminals. It's just responsible of displaying. They are not controlling anything. The scope is not regulating anything. Is not changing anything at all. Okay, it's trying to just visualize the signal you input to it. Okay, this is the concept. So pretty much you're controlling how to display rather than how to change the given signal. Display it in a nice way. Probably want to move it up or down, right? So here, smaller knob is for that. A smaller knob is for that. Yes, 4 of them, of course, 1 for each channel signal. And one more thing down here. This is what. Anyone read?
Intensity.
Exactly. Intensity. Okay, just the intensity. Yeah. It's the intensity. Intensity is also very meaningful. You want brighter or darker of your whatever displayed in the screen, right? It's just very simple intensity. And then this is what. Remember what I said, you need to save the scope result, right? Scope result. By result, I mean the image, right? Waveform. You generate some nice waveforms. You want to save it for your report or your personal record, right? Plug in your USB drive, right? This is the port. This is a USB port. And this is a test port. Yeah, this is a text port. And it itself can generate a square wave, PWM wave. You have to try it when you face the real equipment. These are the basic feature. And here, based on what we have learned, so can anyone tell me what this knob for? Meaningful enough by the arrow here, right? Anyone can tell what?
Control moving left to right.
That's right. Okay, just moving left to right. Okay? You're moving your signal left to right along the horizontal time axis. Correct. And the run control here is a little bit tricky. Run control here is actually when you display a signal, it might moving. It's not stabilized. Yeah, so how can you make it stabilized? You can click stop. You can click stop or single if the signal is periodic. Okay? You can watch it. You can watch a stabilized, nice waveform. And the trigger I have to explain during the lab. And another thing is also very useful is how to save the image. First of all, you insert your USB driver, and the second, the button is here. Save and recall. This is the button you need to press, and then a dialog window popped up. Accordingly, you choose where and how to save the image. Okay, I will teach this more when we use the scope. This knob, there's another knob here. This knob is for what? This knob is the selecting knob. What does it mean by selecting? There's some dialog menu here popped up. You need to choose different options. For example, choosing different way to display, choosing a voltage or current, etc., etc. You need to moving your cursor, right? There's no touch pad for you to move the cursor, right? So this is the select knob. You can change the option. And the cursor here is for mirror. Okay. What does it mean by mirror? The cursor can be used to mirror things. The cursor will give you 2 cursors horizontally and the 2 cursors for vertically. You can move them to anywhere you want to mirror the difference in between. In the waveform, you can measure some like time span. You can measure the how big is the waveform, etc. And this quick measure is very, very important. Look at the screen here. Can anyone tell that these two information are telling us? This is actually the result of using the quick measure here. It's showing your measured results, what the scope is measuring right now.
So it looks like the frequency and then peak to peak voltage, maybe? I
Very
think that's
good.
Millivolts.
Very good. Frequency and the peak to peak. Okay. Of course, peak to peak is 12 millivolts and the frequency is low signal, so it's not testing any frequency. That's fine. But another key thing is the frequency of the peak to peak voltage of whom. Because once again, you have up to 4 channels, you have up to 4 signals. So frequency is the peak to peak value of whom?
Of the first channel?
Exactly right. And this is something very important. You need to be careful is which channel. Okay, so parenthesis of 1, yellow 1. Very nice. It's again color coded. How to select frequency and the peak to peak value for channel 1. I will teach when we do it in the lab. But at least you know how to read this. So quick measure, this button, very useful. I mean, yes, you can know the signal magnitude and the frequency by reading what the division up here, right? You can do that. However, no one's gonna guarantee you the signal is occupying integer number of divisions, right? Fractional divisions cannot be read, no way to be accurate, I mean, right? So you have to do this measure, right? The scope is equipped with measurement feature. Okay, you need to use that to tell you what is the magnitude, what is the frequency, what is the period, whatever you're interested in, okay? Rather than count the division yourself. Well, by roughly estimating, you can do that. However, here, remember to use the quick measure to tell you. And these are basically all of the basic features we use pretty much every single time. One more thing. The cable for this 4 BNC channel input is equipped cable. It's not any cable we want. Okay, we need to use the equipped associated cable. They're all hang against the wall. When you find a cable, because you're able to connect the input signal, right? Those cables are equipped cable. By reading, you can tell they're labeled at Agilent or Keysight. There's a company name on it. It's not any other BNC cable. Well, of course, I don't need to teach you. This is the turn on off switch. Of course, here, these rubber buttons right below the screen also help you choosing different menu and options. You will see how to use them. And our model in the lab, there's no such thing, okay? Because this model is DSO 6034, and the one we are using is 5034.